All right, hey guys, today we're going to go over lesson 5.5, the first half of it, and then we'll finish the second half of it on Monday. So you guys need your math book and your notebook for today's lesson. All right, as a quick warm-up, I'm just going to do number 1, just as a quick refresher. It says, use the table to find the constant rate of change in population per year. Okay, if I want to know the rate of change, a couple things that you could do is you could kind of look for a pattern here. You could see how much it's going up in both of these. Or you could do the y minus the y over the x minus the x to find the slope or the rate of change. Right away, I kind of notice on this one, it's going up 500. It's going up 500. It's going up 500. Okay, that was one way to kind of do it. And over here, it's going up 10, up 10, up 10. Okay, so if I did my rise over my run, it's 500 over 10. If I do 500 divided by 10, that ends up being 50. So it looks like my constant rate of change is 50 people or whatever it's working with per year. 50 people per year. I just found my rate of change. Okay, now I'm going to add this to it. What if I wanted to find, actually, I'll just do that. There is my rate of change. All right, so today we are going to be working with something called a nonlinear function. I'm guessing you can sort of guess what that means. But after today's lesson, you're going to be able to determine something, determine if a function is either linear or nonlinear by looking at the rate of change, the shape of the graph, or the structure of the equation. So you're going to be able to, if I give you a graph, tell me if it's linear or nonlinear. If I give you a table, if I give you an equation, all kinds of different stuff. And that's what we'll be doing. All right, so sort of as a little launch to this lesson, I just want you to kind of think about this. So hopefully you guys know what a field goal is in football. But if you don't, it's where a player holds the ball and a player kicks it between the two goal posts. There are lots of factors that a football kicker has to consider when they're kicking a field goal. The tilt of the ball, it says, has to be held at a certain angle, how far away they are from the ball, if there's any wind or weather, how the holder holds it. They have to determine how many steps away from the ball their starting position will be and how they'll approach the ball. So there's kind of a lot that goes to it. So it says down here, a football is kicked at an angle of 30 degrees. Okay, so I've got my kicker and he kicks it. The angle is 30 degrees when he kicks it with an initial velocity of 30 yards per second. So it's traveling 30 yards every second. The table shows, if I look at the table over there, the approximate height and the horizontal distance traveled by the football. One of these relationships is linear, the other is not. Can you tell which one and how do you know? So I kind of have two things over here. I'm looking at the time and then I'm comparing the height, how high the football is in the air, and the distance, how far it travels. One of these is linear. Which one do you think it is and how can you tell by looking at the table? All right, so here's kind of what I would do. I would start kind of looking, is there any kind of pattern? Well, here, my distance looks like it's going up 13 every single time. That's a constant rate of change. That means the distance is probably linear from where I kicked it from. The height, if you look at this is not going up by the same amount every time. Okay, if I did 9.7, take away 6.2, I get 3.5. If I do 10.5 minus 9.7, if I kind of do that, I do not get 3.5. So not the same answer. So that is not linear. So the distance is linear. Now, let's think about the height of a football. If I kick a football, it's going to go up in the air. Then you guys might notice it reaches a high point. Then it starts to go back down. That's definitely not linear. That's not travel. That's not, the height is not a constant rate. It doesn't keep going up because it goes up and it's going to come back down. So that would be nonlinear. All right, so let's actually jump right into our math book. It says, if you want to identify linear and nonlinear functions from a graph. All right, so linear functions are graphs that are straight lines because they have a rate of change between any two data points is constant. Okay, so if I came down to this graph down here and I pick any 2 points on the line, the rate of change or the slope is going to be constant. We learned that other chapters. That makes a straight line. Okay, so that's called linear. Nonlinear functions, okay, you guys read kind of up here. Nonlinear functions are functions whose rates of change are not constant. Okay, so they are not constant. Therefore, their graphs are not straight lines. So if you take a look at this, it is not changing at a constant rate. It starts out kind of slow, and then it starts getting faster. That is not a constant rate. So their graphs are not straight lines. That's called non-linear. Okay, it's still a function because it passes the vertical line test, right? Crosses once, crosses once. It's still a function. It's just not linear. So if you flip to page 294, this is not too hard to tell. So it says determine whether the graph represents a linear or a nonlinear function, and how do you know? Okay, so it says what are some characteristics of a linear function? Remember we talked about it has to be a straight line, and it has to be a constant rate no matter what 2 points you choose on the graph. Okay, so if I take a look and I chose this point and then maybe this point and this point, this one looks like it's down 1 over 1. Okay, so my slope is negative 1 over 1. Here, this looks like it's up 2 over 2. 2 over 2, that's the same as positive 1. That is not the same constant rate. So it's not exactly a straight line because it goes and then it turns. So that's not a straight line. And it doesn't have a constant rate. So I would answer no. So the function is nonlinear because the graph is not a straight line and it does not have a constant rate of change. Now it says, well, it's kind of composed of multiple straight lines. Why is it still nonlinear? And we just kind of talked about that because of the rate of change. All right, you try the check on page 294. Is this one linear or nonlinear? All right, so pretty easy. First of all, it is a function. If you guys kind of just test it, crosses only once, so it's a function. And then is it linear or nonlinear? Well, it's not a straight line. It's pretty easy to tell. It's not a straight line like this, so it is nonlinear. All right, so let's look at example 2. It says, this is on page 295, a square has a side length of s inches. So I don't know the exact side length. The area of the square is a function of the side length. So I'm going to tell you it's a function already. It says graph the function to determine if it's linear or nonlinear and then explain. All right, so before we get to graphing this, I want you to think about, well, what do I need to do before I can actually graph this? I mean, it didn't really tell me too much about this. Well, it says step 1, you're probably going to make a table of values. Okay, so I just want to think about what I know about squares. So if I have a square, okay, and I want to find the area of a square, it's whatever number this is. If it's 4 times 4, it'd be 16. Okay, squares have the same side lengths. So I'm going to pick some different side lengths. So if I have a square that has a side length of 1, I would do 1 by 1, which is 1 would be my area. A square with a side length of 2 would be 2 times 2, which would give me an area of 4. 3 times 3 is 9. 4 times 4 is 16. 5 times 5 is 25. All right, so that would be my table of points. All right, next it says, well, let's actually graph it. All right, so a square with a side length of 1 has an area of 1. So 1 comma 1 would be right there. That was in the table. 2 comma 4. A square with a side length of 2 has an area of 4. 3 comma 9 would be 3 comma 9 up there. 4 gave me 16. And 5 gave me 25 way up here. All right, if you guys look at these, they do not make a straight line. It looks more like a curve if you kind of see this here. It is not a straight line. If I pick 2 of those points, it's not a constant rate of change. So do the points lie in a straight line? No. So it is a non-linear function. Okay, now if I was going to kind of connect this, I could do a square with a side length of 1.5. That's possible. So there are points between here. It could kind of look something like this. I could even come back to here. 0 would be 0 there. So there's what we have. Okay, let's try the check. It says a cube has a side length of s meters. So think about a cube here. Looks something like this. And it says the side length is s. So if that side's s, so is this side, so is this side. Cubes all have the same length. It says the volume of a cube is represented by the expression s cubed. Basically, to find the volume of a cube, if you guys didn't know this, you take the length times the width times the height. So basically, you're doing whatever the side length is, the side length times the side length times the side length, which is the side length cubed. Okay, so it says the volume of a cube is a function of the side length. Is this linear or nonlinear function? Okay, so they already kind of made a table of points for you. They said, okay, if I had a side length of 1, well, 1 times 1 times 1 is 1. If I had a side length of 2, I would do 2 times 2 times 2, which is 8. A side length of 3 would be 3 times 3 times 3, which is 27. And then 4 would be 4 times 4 times 4, which is 64. Now they graphed it for you already. You guys take a look at it. You can see it is not linear. So it's a nonlinear function. And it says explain. I could say 2 reasons. Not a straight line. And not a constant rate of change. All right, so let's go ahead and in your notebook, let's just take notes about what we learned in the first half of the lesson for today. So I would make a new page, 5.5, linear versus nonlinear functions. That's what I would put for the title. All right, so I'm going to put, kind of make a column, linear functions and nonlinear. And we're going to add some more stuff to this next week. But at least you kind of have a start. All right, so linear functions make a straight line if you graph it. And they have a constant rate of change or slope. Okay, nonlinear functions, not a straight line. Okay, and do not have a constant rate of change. Okay, obviously if you were going to draw like a sketch of a graph of a linear function, it looks like that. Nonlinear functions, it could be like a curve. Could be like a V shape. Okay, those would all be nonlinear. And we are going to learn even more stuff next week. So today we just kind of looked at graphs, if they're linear or nonlinear. And then next week we will look at tables, equations, and a few other things. All right, so hopefully that wasn't too bad. Your learning goal for today is, can you identify if a function is linear or nonlinear based on a graph? And could you explain to somebody what linear means and what nonlinear means, and if it is a function? All right, now you can go ahead and work on the worksheet that goes with this lesson.